Would you have
Okay.
found it? No, but what's important about that? Knowing these important things like, is it a deterministic algorithm? And, how, when you hear the word unique, you should immediately think, oh, this is a set. I need some function
Right, right.
that's hashable, so it can go into a hash set or a hash map or something like
Hello?
that. Hello, good afternoon. How are you doing today?
Good, how are you?
I am doing pretty good, thanks.
Awesome. Good to hear.
Sorry, I'm a little late here. I was kind of expecting it to be connected, and I realized it was waiting for me to click a button. So,
No worries at all.
hey, great to virtually meet you. In order to help me target this interview a little bit better, it would be helpful if any information you're willing to share on like where you are in your career, what types of roles you're targeting, any experience you may have.
Yeah, definitely. So I graduated from college last December, and currently applying for full-time positions after I had a position at a FAANG company and it was rescinded or delayed a significant amount because of all the hiring freezes and stuff.
Mm-hmm.
I had 2 internships with them, and so right now I'm working up and doing prep for technical interviews for companies. I have a couple that I'm currently like in the process with, but yeah, I just generally wanted to get some experience, kind of in like a real life situation, because it's a bit different, like solving these problems on your own, like on LeetCode or something, versus like having to do it live and with an interviewer. So
Absolutely, yeah. The main difference is you have to say what you're doing as you're solving it. So,
right.
all right, excellent. And just some advice on that. In addition to just getting a professional interviewer like me who actually has done interviews with candidates, there is this peer interviewing thing on interviewing.io. It's free. I think if you are a peer interviewer, for every 2 interviews you give, you earn a free one where another peer can interview you. So it's just a free back and forth thing.
Oh, cool.
If you just want to practice talking to someone, now granted they're just going to be a candidate just like you, but
right.
you learn something interviewing them, they learn something interviewing you, and it's free and it's useful. So just a suggestion.
Yeah, cool. Check that out.
Check that one out. Yeah. All right, great.
Awesome.
Well, let me just jump into it then. The main purpose of there's 2 main purposes of these types of interviews. So when you go to a company, one of them is just kind of the basic, hey, can you code? Do you know a programming language? And so any of the basic algorithmic types of things. Can you do loops and conditionals and know just enough about computational complexity to not write stupid code. So that's kind of the goal. And there's kind of going to be 2 halves of the interview. You'll kind of see the first part, or sometimes there's one problem that gets complex, or sometimes there's 2 different problems. But you'll kind of get an easy problem to solve to write the code. And then as it gets further on, either it'll be a harder problem that you have to explore some unique aspects of, or you'll just get peppered on more detailed questions, or hey, do this a different way, even if it's not the best way. But you'll have to answer questions about trade-offs and more detailed, in-depth knowledge. And
cool.
Basically, don't worry if you can't answer something. The interviewer is probing to find your breaking point. If you ace the interview, then the question wasn't hard enough. So
okay.
they're gonna raise the level as needed until they find out where your breaking point is. Don't worry too much about style, capitalization, underscores, camel case, all that kind of stuff, typos. It's mostly the algorithms we're going to be talking about. Most important part here, though, do please think aloud. The worst thing you can do is just sit there and struggle along silently and make me try and understand what you're thinking based on reading your code. And don't worry about mistakes. 90 to 95% of the time, maybe even higher, you're going to make a mistake. It's fine.
Right.
You're nervous. Everybody does that. It's not a killer in these things. So as long as you find, either find it yourself, or when prompted, if you quickly say, "Oh, this was a stupid thing," and fix it. That's typically that is extremely common in interviews and doesn't really hurt you. It's stuff that you would your IDE would normally catch.
Right. Okay.
Great. So in the upper right corner of your screen, you will see a drop down, a language drop down. Currently says plain
Yep.
text. Feel free to switch that to the language of your choice.
Cool. Go ahead with C++ if that's okay.
That's okay with me. It's not. It's a challenging language, so good luck to you in that. But all right, and I am going to go ahead and paste a question here below where that current text is.
Cool.
And let me see if I can figure out. It is a standard /* comment file comment style. Okay, so here's your question. I am giving you a two-dimensional array of integers, and you can see the example on line 20. Ones represent land, and zeros represent water. So you can think of that as an ocean with a bunch of islands in it. Mm-hmm. And there are currently 4 islands in that ocean. And you can see one in the upper left-hand corner, kind of an L-shaped, 3 vertically and 1 horizontally. Yep. You can see that same shape in the third column down near the bottom. And then in the second row, third column from the right, you'll see a third island. It's 2 ones on the top with 1 below the right-hand side. And then in the lower right-hand corner, there's 2 ones on the top and 1 below the left-hand side. So basically, when we're talking adjacent, it's only the horizontal, so north, south, east, west, or left, right, up, down, if you want to call it that way, not diagonally, as far as adjacency goes. So there are 4 islands. However, I want to know how many unique islands there are.
Got it.
And the key here is the one in the upper left and the one in the third column near the bottom are both identical in shape. You can see the shapes on line 32. There's 3 different shapes. So that's what the value I want to get. And go.
Okay. All right. So yeah. So just from taking a look at this, thinking about some of the edge cases we might need to handle for. So are there any guarantees about the minimum size of the 2-dimensional array?
Sure, I'll tell you it's not empty, so you at least have 1 row and 1 column.
Okay, got it.
And I'll also give you that it'll be rectangular, so you can assume that the length of the first row is the same as the length of all the other rows.
Okay. Yeah, so this is an interesting problem. Just thinking about it kind of in 2 different stages in my mind. One would be identifying islands, and then the second problem is that we only want to count unique islands. Mm-hmm. So I think that's the interesting aspect of this problem to solve. So starting off with figuring out how many islands there are, I'm thinking that we would, the basic solution would be an O of n times n, or length, width, and height complexity. And the same space complexity, we'd essentially loop through with a doubly nested loop through all of the elements in the 2-dimensional array. We would keep track of a visited 2-dimensional vector as well. And this visited array would make sure that we don't visit the same cell twice. And essentially, if we find a 0, we would mark that square as visited and continue on. And then if we find a 1, we could have a separate function that essentially traverses through the array, marking each cell that's visited, and discovering exactly where the extent of the island is using the 4 cardinal directions. But that would just count the number of islands. So additionally, we're going to need to figure out how many unique island shapes there are. And so just thinking through that, about how we could determine whether or not the islands are the same or not. One thing that comes to mind would be trying to make all the islands generic to a zero index. So that we would easily be able to compare their dimensions. So for example, when we have this island in the top right and this island here, we would zero index the top left of each unique island, which would be the first time we encounter a 1 for that island before we recursively search. And then after we find all the unique islands and store their the coordinates of each one within that island, we would then loop through that new structure that we've created and only count them if we haven't seen that same structure before.
Okay.
So that's the first way to track if they're unique islands that comes to mind. Trying to think if there would be another way.
That's a pretty good intuition. Okay, go ahead.
Okay. Yeah. I'm just thinking if there would be another way to do that. Because I don't think it's entirely simple, and it does require us to go back through, create a data structure storing all the island information, and then go back through that again.
Okay. Are there any data structures that are particularly well suited for removing duplicates?
Yeah, I mean, with sets, you can only store one of each element within it.
Okay, so that might save you the going back through it a second time step.
True, yeah. To be honest, I'm not sure how set comparisons would work with, if you had a set of vector indices of the so you have a set, and each element within that set is a vector of indexes of where that island is on a zero index scale.
Mm-hmm.
And then you could just return the length of that set. But yeah, to be honest, I'm not sure how set comparisons work when it's not a single element within that set. Like I said, if we have a set of vectors.
Okay. Well,
if we would need to establish our own comparison function or not?
Okay. Well, so maybe you would, but maybe you can also turn it into a single element. What kinds of sets have you dealt with in the past?
Yeah, interesting. If we could turn it into a single element, that's a good idea. Because what if we zero indexed all of the islands, and then instead of storing a vector of the indexes of the islands, what if instead you stored some sort of a sum of all the indexes? Then that should be unique for each of the island shapes.
Okay, you're thinking in the right direction. Let's table that conversation for later. You mentioned earlier kind of separating this to two problems: one, finding the islands, and then finding the unique ones. So let's go ahead and do the first part, and then after we're done with that, maybe we'll revisit this second conversation.
Sure, sounds good. Yeah, so you can go ahead and write. We'll need two functions to do this. So we're returning an integer, which is the number of unique islands. So find islands, and then we're given a two-dimensional array of integers called islands. So additionally, on top of that initial data structure, we will also need a two-dimensional visited array. So just initializing that with -1 for not visited. And we have a visited array. Then we would need a doubly nested for loop. And then we can store it as an integer, current tile, islands, row, and column. So we can say if current tile is equal to 0, otherwise, and just to clarify, there will only be zeros and ones in the array. We're not going to get any sort of like bad input.
Sure, for now, that's a good assumption.
Okay. So if current tile is equal to 0, then we simply mark that as visited. And then we also want to check that we're not revisiting the same square here. And then, so if current tile is equal to 0, we simply mark it as visited and continue. Otherwise, the current tile would be 1, in which case we would need to find the islands, and we can use find single island. And for this, I'm thinking we'd need another function that essentially would recursively search through the two-dimensional array, looking for all instances of that island. So call it find island, I guess. The parent function is called find islands. We need islands. We need visited. We need row, column, and then so this function. Takes in islands, takes in visited, takes in row, takes in column, and then if we've already visited, don't care about that. Otherwise, we'll mark this current square as visited. Then if the spot we're on is a 0, then we would simply return. We've already marked it as visited. Otherwise, this is the case where we need to then recurse in all cardinal directions. So if row minus 1 is greater than equal to 0, this means we can go left. If row plus 1 is less than this means we can go, or sorry, this is up, down. If column is 1, if column plus 1, and so then this is up, or sorry, this would be left and right. And then what we would do is marking as visited, we would call find islands, islands visited, row -1, column. Row +1, and then we want to search right. Or sorry, we want to search left, and then we want to search right. And so then once we encounter a single, the start of an island, and we haven't seen that island before, or any piece of that island before, so we should be entering each island at the top left corner of that island. Then we enter into this function, find islands visited, row and column. And if we've already visited this tile before, then we return. If otherwise we're setting visited to true. We don't care about zeros because they're not part of the island itself, so we don't want to recurse if we encounter a 0 tile. And then otherwise, if we're not at an edge of the array, then we want to search in all 4 directions for other island tiles. And then essentially what this will do is mark every single tile of that island as visited. So then each time we find a unique island, we know that that is the only island. So this essentially solves, I haven't put any return here yet because the question was asking for unique islands, but if we wanted to find every island, we could simply like increment some sort of islands counter and then return islands at the end.
Okay, great. So I think you've effectively found all of the islands. So let's go back to the question of uniqueness. Yeah. Let me just ask a question about your algorithm here. Will you always visit, when you're navigating these shapes in that second, the line 35 method or function? I forget what the name in C++ is. I'm a Java guy. But line 35, when you call that, will you always navigate the island in the same order? Like you were saying, you're always going to start in the upper left. Is that always going to be true, and so forth? Can you?
Yeah. So because we're marking all of the successive island tiles as visited, there's no way we could enter an island in any other tile other than its top left, the top left one of that island. So we should always enter the island at the same spot. And each time we find a single tile, we're always looking for those islands in the same order.
Okay.
We're looking for the rest of the tiles in the same order. We're looking up and then we're looking down. Yeah, interesting. If we're gonna, because once we go up, then we're in a new tile.
You got quiet.
Just thinking,
so
about,
thinking about something.
Yeah, yeah. Just to clarify, I'm just thinking about that question of if we'd always traverse the island in the same exact order.
Yeah, I mean it's kind of a bigger question here, like on a search of the style that you're doing here. Is the order guaranteed or repetitive, or what's the word for predictable?
Deterministic.
Deterministic. Thank you. That's the word I was looking for. Bonus points for you filling in the blank for me there. Yeah. So that's the question: is there a deterministic algorithm here? And I think you're saying it is.
Yeah, I think it would be, since we're always recursing in the same order. We're always going to go up as far as we can.
All right.
Yeah, I'm pretty sure it would.
All right, great. So knowing that, let's go back to your idea of trying to come up with something you can stick in a set that
Yeah.
will help you remove those duplicates very well. So, what kinds of data are you used to putting in your programming past? What have you put in sets?
Yeah. I mean, usually, like, I guess I'm not sure the term for it, but like single item variables. So like integers or, I guess no, because I put, you can put strings in sets. You can put, um,
Okay, and yeah, you can put
yeah, I mean,
any
I
that
would say I
you can
put a
generally
variety of stuff and put anything. Yeah.
you can put anything in, and as you mentioned earlier, you just need to come up with some sort of a method of making sure that all resolves to some unique number. But let's explore the
Right.
string.
Right.
Let's explore the string option, knowing that you're always going to be going in these same directions. Um,
Oh,
or
interesting. Yeah.
or you can your relative coordinates or something. Is there a way you could just build a string dynamically and end with a string that describes the shape?
Yeah, definitely. And string comparisons are very easy to do. So, I think that would, and like, I mean, we don't even need to do string comparisons because we just throw it in a set. But yeah, um, I mean, essentially, I'm thinking you could store like essentially. Uh, so let's say here we have a string called I don't know, call it island or something, and then we go ahead and pass this in to find island. And then what I'm thinking is every time we travel in a direction, we would append to the string the direction that we're traveling. So each island that has the same traversal that follows the same direction um, would end up with the same string. The one thing we do need to handle for is that we're not checking if the island is 0 ahead of time. So you'd get a lot of extra junk in the string. You wouldn't just get the directional of the 1 tiles. But I think we can definitely still do it. I think it just requires tweaking a bit of how this find island works. Yeah, so we pass it in by reference. So as we go through this recursive path, we're going to keep updating island. And then at the end, this island string will contain the entire directional input that we use to find that island. And then we would just push the island into the set, and then we can just return the set length at the end.
All right.
Okay. And I'm actually not sure the exact syntax for a set in C++. Do you mind if I just Google that real quick? Is that okay?
Sure, go for it.
Okay.
That would probably not happen in a normal interview, but this is practice, so I'll let you do that.
Okay. Yeah. Definitely not something I use regularly, but it's a good reminder that I, should practice with it more. Okay. Okay, so this should handle the find islands function now. And now we just need to handle this. So because we don't want to because if we just append like the direction here to the island string, what would happen is that we would get like a lot of extra directions for all of the zeros. So, I mean, we could solve that pretty easily, I think, just by doing a check before we make the recursive call of like what tile we're trying to go into.
Okay, well, let's pause for a second. Is it a bad thing to have a bunch of junk in your string, or?
Yeah, I mean, we're traversing always in the same direction. So, I mean, I guess it wouldn't necessarily
Let me give you a hypothetical look ahead. Look down at line 90,
sure.
which is where these examples have gone. And take a look at the right-hand two islands. They're both going to involve going right once, and they're both going to involve going down once, but they are different. So how are you going to distinguish between those two in your algorithm?
Yeah, interesting.
If you only store the directions, they would both have right down or east south or whatever those are. So you need at least something to say, hey, I'm moving my start point.
Right. So essentially, like as we're backtracking through, so we needed to track what direction we're going in addition to what direction we're going when we backtrack. Correct?
Correct. Yeah. I'm also just saying that this extra junk that you're trying so hard to get rid of might actually be useful there. So I'm just saying, don't rush to get rid of it.
Okay. Yeah, interesting. So what if instead of I mean, I think we could say just back up. Something like this to track when we've returned from going upwards.
Okay.
Whoops, this says islands. Because essentially I'm thinking when we're looking through here, we wanted to track what direction we're going, and additionally when we're returning from that direction. Because here we're going right, but once we've gone right, there will also be coming back from going right. Whereas in this string, the order will be different, right? Because we're going to go right, but instead of going back right in the same order, we're going to be going down before we encounter that back right. So the strings will be different.
Okay. Yeah. No, I see it. That looks good.
Okay.
Might be shorter with just a single character than the entire word.
Yeah, true.
It looks good.
Yeah. Okay. So we want to concatenate the string. Yeah, just complaining about the quotes here. But we want to concatenate the string as we traverse through each island. And then at the end, we're pushing this string back onto the set, and the set can only store unique elements. So if we encounter the same string twice, that should not be added to our island list. Yeah, and so then we push it onto island list, and then at the end, we can just return island.size.
All right, that sounds great. Okay, this looks good to me. One question I did want to ask, so you mentioned when you added that island parameter to pass around, you made a comment about you passing it by reference. Can you explain why you said that?
Yeah. It's because, like, so let's say we add island up here. Yeah, I'm passing it by reference because we want the value through all of these recursive functions not to be copied, but instead just to retain that same initial value. And also because we're not returning from find island, we're simply passing in island. Like, I mean, you could do it where you're like concatenating a string, change this to a like string return. But with this way, we can just pass the variable in by reference, and then island is automatically, like, islands change once we get down to line 28. Because we pass it by reference, this initial variable is going to be altered every time we're concatenating the string.
Oh, okay, great. Do you know the word for being able to alter a variable as you pass it around?
I'm not sure. I'm not quite sure.
Oh, come on, you're going to lose the bonus point you got for deterministic.
Yeah, I know it's pass by value, pass by reference.
Mutability was the word I was looking for. That's all right. It's fine.
Okay.
Hey, great. We have some time left, so I want to jump to another problem here since you've pretty much solved that one. So I'm going down to the bottom of your screen here. And this one, you don't need to write any code for. I would just like you to talk about an algorithmic approach that you would take to this. And just, say anything that comes to mind in terms of, hey, this reminds me of like this type of a thing. Starting on line 105, it is a very succinctly a written problem, but it ends up kind of being a little bit more complex once you start thinking about it. I would like you to write a function that rounds an integer to the nearest power of 2. So here's two examples. If I give you the number 800, it should round up to 1024 because that's closer than 512. And if I give you 1500, that should round down to 1024.
Okay.
And I'm going to give you another bit of information that assume this is going to be like on the hot path, and it really needs to be optimized to be the most computationally efficient as you can possibly get.
Right. Okay. Yeah. So I can definitely talk. I think there's a slower approach and there's a faster approach. Before that, are there any guarantees about the polarity of the integer? Like, can it be negative?
Sure, I guess. I'm trying to think how I would even handle that. Actually, no, I'll say powers of 2 are always going to be positive. So assume it's a positive, positive integer.
Okay.
So if you want to use an unsigned data type, so it's always it's guaranteed positive, that's fine too.
Yeah, that does bring to mind that, like, do we have any guarantees about the size of the integer that we're being given? What comes to mind when you say unsigned is that if we're given an integer that's close to the maximum integer of like a regular integer variable type, trying to find that larger value would overflow the integer?
Sure. Yeah. Well, let's just say it is. It'll be within a 64-bit value.
Okay. Yeah. So in that case, I'm thinking. So like the slower way to do it is just essentially what we want to do is we want to find the power of 2 less, and we want to find the power of 2 greater. And then we just want to compare and find which one is closer.
Okay.
So the slower way to do that, so we have our initial starting integer, starting with the power of 0, which is 1, and then you just increment, go to the 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, and just like continually doing that until we find the first power of 2 greater. We store the previous power of 2 that was less than as we're finding that greater value, so we have the 2 values to compare. But yeah, faster way to do that just would be to do like a binary search. So instead of incrementing by 1, Well, the initial faster way would just be to like, thinking about, so I know we want to do some type of like logarithmic search, because that would be much faster than just incrementing by 1 every time. What I'm thinking about is like how we would find that initial value to binary search over.
So I'm liking your intuition here on binary search. Let me
Yeah.
just throw a question out there. What, irrespective of this particular question, when you think binary search, what are kind of the requirements in order to search something that way?
Yeah, you need to have a minimum and a maximum, and that's what I'm kind of thinking about. Is like, I'm thinking about how we would find that like maximum value, that initial maximum value.
Well, I mean, if I tell you
Because
if I tell you it's a 64-bit number, then that might be your maximum, right?
Oh yeah, yeah, true. Yeah. So I mean, then like with the binary search, you have your minimum value, which would I guess be 0, and your maximum value, which we could just set to like an int max, and then we would binary search based on like taking that value. Well, the thing I'm thinking about is like if we set int max to be the maximum, then when we try and set that number to the power of 2, it's going to overflow. Because essentially what we want to do is have the search space every time we iterate. We have a minimum and a maximum of integer max. I mean, you could just do like, instead of setting the maximum value to be integer max, you could just do some sort of computation beforehand to find 2 to the power of what gets us as close to possible as integer max without overflowing, and then set that to the maximum.
Okay, so good intuition there. So what is integer max? If I tell you 2 to the power of something is integer max, what's that something?
I'm not sure. I'm sure there's a fast way to do that.
Well,
but I'm not sure.
If it's a 64-bit number, what's the largest 64-bit number?
You know, I'm not sure off the top of my head.
Let's go to the easy one. What is the largest 8-bit number?
Yeah, I'm sorry. I'm not good. I'm not good with. Yeah.
Okay.
You found my breaking point.
I found your breaking point. What's the largest 1-bit number? Largest. 2. Okay. What's the largest 2-bit number?
4. Okay.
Are you following now? So the largest 8-bit is going to be 256, right? So 2 to the whatever number of bits is what you get, and there's a -1 involved here. So the yellow brick road I'm leading you down here is when I'm giving you these integers, really all you have is a array of bits that are all either 1 or 0, which you can represent. Those are all just a sorted list of numbers between 0 and 2 to the whatever 63rd. But the point here is that your number, you're looking for the most significant 1 in this list. So you had a fantastic intuition of you need to do some sort of a logarithmic search, and you even called it binary search. In a binary search, you have a sorted list of numbers or whatever that you're going through, and those bits are actually, they represent numbers. Each bit represents a number: 1, 2, 4, 8, 16, and so forth. So
got it.
So
you can binary search on the array of bits.
Yeah. So now, given all that information, let's go back to your algorithm. So you want to have your search space. How are you going to do that?
Yeah. So I mean, yeah. So the way I initially conceptualized with this was like simply like using numbers, but you're talking about having the search space within an array of bits, correct?
Yeah, correct.
Okay.
Let's go really easy. You have a 2-bit number. I'm thinking of a number between 0 and 3, and I want you to guess it in only 2 steps.
Yeah. So if you have a 2-bit number, then your middle value is size minus 1, and you make that bit 1.
Okay. So if my possible numbers are 0, 1, 2, 3, and I want you to guess it in only 2 steps, the first thing you're going to do is you're going to ask if it's smaller than 2 or at least 2, right?
Yeah, you could do that as well. I mean, I was saying go to 1 first, but you could also go to 2 as well. Yeah.
Yeah. Okay. So basically, that's going to be your approach. You'll split the number in half bitwise. So a 64-bit number you will split into a 32-bit number.
Okay.
So basically, you would ask the question: is my number bigger or smaller than 2 to the 31st?
Right. So you
And
would
if it's
take your first integer and you would find the highest index where the bit is 1.
all you need to do is ask the question: is it bigger or smaller than this number? And then continue to logarithmically iterate, chopping the thing in half, with a little bit of complexity of some bit shifting in the middle, which that's okay. Since we've identified this as your weakness, I don't think we're going to get there with this question. But
Yeah.
I do want to compliment you, though. That intuition of a logarithmic search that's what most people miss in this problem, and you had that right up front. You just didn't quite have the details to get it there. All right. Hey, great.
Yeah.
We have about 10 minutes left in this, and you've done really well. I want to just kind of open this up for you to ask any questions you want. If you want, I can give you live feedback, but I'll give you also some detailed written feedback afterwards. So if you just have any other random questions about interviewing process or just overall in general, I'm happy to give the rest of the time to you to use as you please.
Okay, cool. Yeah, some live feedback would be great, but I guess first, like maybe like when you've been interviewing, like what are some things that you've learned that have maybe been like kind of like you think have really helped your performance within these like technical interviews?
Sure. There are actually there's only a small number of actual types of problems that can be asked.
Okay.
And the reason is, and I've even gone into interview hiring training, and they're like, yeah, you have to have this special, it needs to be hard enough, but not too easy, and you have to be able to measure all of these things out of a single question. So there's
Yeah.
a fine-tuned calibration to getting just the right question, which you might notice the question I asked kind of meets that. There's an easy solution, and then it starts to get more complex, and then you're digging into all these unique, aspects of it. So that's why it's one of my favorite questions. There's some other really good questions out there. Boggle is, if you've ever done the Boggle question, that's also a particularly good one.
No, I'll write that down though.
Yeah, if when you boil it down, there's really only like 7 different data structures to know, and maybe about 10 or 15 different algorithms to know, and every problem is just some combination. Every problem's a combination of those.
Yeah.
So have you ever seen the site? I think it's called LeetCode. I'm typing the name here on line 119. I think it's LeetCode.io.
Yep, that's pretty funny actually. I usually just do like LeetCode, like blind. I was like doing blind 75 for a while.
Perfect.
But just like last week, I heard about LeetCode, and I've been like kind of using it to go back through some problems I haven't done in a while, because like it'll take you from like kind of ground zero with just like arrays and strings up to like 2-dimensional dynamic programming problems. So yeah, it's a cool website. I've actually been using it recently.
yeah, it's kind of probably one of the best websites because it covers all the different types of problems that you're ever going to possibly see. So if you are comfortable with solving those
Yeah.
75 or 150 problems, you don't need to do every single LeetCode problem. Those kind of cover it, but don't focus on just solving the problem. Focus on how do I do this? Why do I do this? Like, up in
Okay.
our question that we solved, I'm sure that that's actually a LeetCode question somewhere. I think it's one of the hidden ones that you have to subscribe to. The counting islands is
Okay.
available, but the counting unique islands is one of those. You need to be a member to do this kind of thing, but it's there.
Yeah.
Would you have
Okay.
found it? No, but what's important about that? Knowing these important things like, is it a deterministic algorithm, and how, when you hear the word unique, you should immediately think, oh, this is a set. I need some function that's
Right. Right.
that's hashable, so it can go into a hash set or a hash map or something like that. And you kind of need to know, okay, what does a hash function actually mean? If I had to write one for a vector, how would I do that? And just do
Okay.
those
Mm-hmm.
mental exercises. It's not just about solving the problem. It's kind of exploring every corner of the problem. You know,
Okay.
I I used to sometimes I used to ask to sum, which is like one of the simplest LeetCode questions you can get, right?
Right.
But it's like I wouldn't just say, hey, solve it. I would say solve it all three different ways. And you would have
Yeah.
to
Yeah.
go through those, and then I say, why is this one better than that one, or what are the advantages and disadvantages of each one of those? And you would kind of have to go through that. There's some other cool problems. Have you heard of threesome?
Yes, I have. Yeah, I've done that one a number of times, and every time
Yeah.
it's difficult.
Yeah, but I mean,
Yeah.
really, all it is it's two sum, which is trivially, and
Do
the three
some
different
with
ways
an
to do
extra.
it,
Yeah. Right.
with a loop around it. Okay. Have you ever
Yep. Yep.
done Pythagorean triplets? Give me. I'm going to
No, I
put you
haven't.
a
I'll write
number.
that one down.
Oh, okay. Well, no, don't write it down. This one's easy. You've got a squared plus b squared equals c squared, right? I'm going to give you three numbers, and
Yeah.
I'm going to ask you for combinations that match that. Do you know what that really is? It's threesome. Uh, it's
Oh,
finding
interesting. Yeah.
it's
Yeah.
so it's cleverly disguised in terms of math. There's a sliding window one where I
Yeah.
like, hey, I'm giving you random XY coordinates on this graph, and then I'm going to give you an angle, and I want you to tell me the maximum number of these coordinates that you can stick into in this angle that you're looking at. Like you've got a telescope, how many stars can you see in it, kind of a thing. And
Uh-huh.
sure, it's basically do a polar coordinate transmutation, and then the rest of it's just like the standard sliding window of how many jobs are running at any particular time, where you're incrementing and decrementing and keeping track of that, and that type of thing. All of these problems are the same algorithm. They're just dressed up creatively in different ways. But you're always going to be either doing a two-pointer iteration like in twosome, or you'll be wrapping that, or
Mm-hmm.
it's it's the same building blocks. So as you do neat
Got
code
it. Got
or
it.
LeetCode problems, kind of uncover what those building blocks are, and every problem is going to
Okay.
fall into one of those. This unique thing is it's basically a depth first search that you're iterating over with a few creative additions to how you're going to do it.
Yeah.
And,
Yeah.
and you can optimize it and things like that. But it's really it's truly just that simple, that type of a thing.
Okay.
So know the different data structures. One thing that that was kind of a surprise here is that you didn't. If you're choosing the language, you should know the all the data structures in it. Set that you would expect to see. So sets and lists and queues. And stacks and stuff like that. So any of the common data structures you're going to see, you should be able to recall immediately by memory. But there's not that many. There's like
Okay.
7 or 8.
Interesting. I've actually been in interviews where they like let you look things up before. But
Yeah,
yeah, you're right. I definitely should
it's fine.
like know those.
For
Yeah.
yeah, for your chosen language, you should be an expert in that language, or at least to that.
Okay. Okay.
And also things like, are strings mutable? They are not in Java, but they are in C++. So that was kind of one of those I had to Google while you were asking a question. I'm like, oh, are strings really mutable in C++? And it's like, oh yes, they are. So it's kind of one of
Oh,
those
interesting. Yeah, I mean, I don't even think about that because I use C++ for so long. It's just like I don't even realize some of the things it gives you by default. So
Yeah. Well, in the real world, people use stupid languages like Java and JavaScript. So have fun joining the professional workforce. But anyways, it's good to
Yeah.
know those things. Otherwise, they're going to bite you later. So, but just knowing, hey, I use this language, so I'm able to do this, and just knowing those little levels of detail kind of help guide it as you go along. But that's
Do
kind of where you're
you
going to
think it's
go.
a detriment to use C++? Like, because I personally have never used it in professional settings. Like between interviews, like internships, like smaller jobs I've done, like I never actually use C++, but it's always my go-to language for LeetCoding, just because like my college education was all in like C++ standard library stuff. So
Yeah, it's fine. It's probably okay because your interviewer is not going to know it, so you can probably get away with a little bit more than you would in other languages. But it's kind of one of those whatever you're comfortable with is a good one to
okay,
use. It's mostly about the algorithms, and then knowing key things like is this a deterministic algorithm? Is this a mutable data structure? And things like that. Pass by
okay,
reference, pass by value. Knowing those little aspects of the language is kind of important. So you're totally fine. It is kind of one of, sometimes you actually run your program. I don't know if your program would actually compile and run. It would be fun to see if it would. But I when I've only
yeah, I was
had
seeing a
like I
lot of
think
weird errors there on those things.
I've only had one other person try and do C++, and they debugged for like 10 minutes because it's like the program looked good,
Right.
but there's all these little subtle, oh, I didn't do this silly thing that I need to do in C++. So I didn't even ask you to run your
It's kind
program
of
because
interesting because like the environment you code in sometimes, like with LeetCode, like you don't have to worry about all these like tiny little errors, but then you get into like this coding environment where like they actually give you the main function and everything like that, where
yeah.
like all of a sudden these like little errors pop up. So it's definitely like a good reminder that like I should practice more with like a real compiler and not just like those web compilers.
Well, doing LeetCode kind of gives you that real compiler, so that I think that tends to be less a problem. In an actual interview, they used to be on whiteboards, so you'd be writing all this stuff on a whiteboard, and nobody's ever going to compile that. But so there's a balance in between those. It's really if you have the most beautiful algorithm and you have a typo that syntax error, so it doesn't actually run. I'm not going to fail you on the interview, as opposed to someone else who did a very
Uh-huh.
simple, computationally horrible solution but got the right answer. Um, you'll still
Okay.
win on that. So the algorithm wins. So that's the
Yeah.
important part. But yeah, having code that works is also pretty fun. But
Okay.
one cool data
Curious.
structure.
Yeah, yeah.
If you're not familiar with it, I do want to just throw one data structure at you, and it's good for that boggle problem. It's called a trie, TRIE. Have you heard of that?
I have. Yeah, I've actually used one of those before, just
Okay,
in LeetCode,
excellent.
never in like a real environment, but yeah.
Yeah, I use it in a real environment every day as a part of a distributed search.
Wow. Okay.
It's basically nested hash maps, but it's a really efficient way. If you're dealing with distributed computation in any way at all, um,
Uh-huh.
that is kind of the way to do it. That a distributed hash mapped type of or hash ring type of a thing is pretty important. So look that up. Look up consistent hashing and hash rings and stuff like that. They're pretty cool things to understand
Okay.
when you get in an interview. All right, great interview. I think you're ready to go. If you want just more practice, I would encourage you to keep doing some of the free peer ones. Interview other people, ask them this question,
Okay.
and you might learn something from their answers
Right,
as
right.
well. And maybe any other LeetCode problems you're doing. Ask your peers those questions, and you'll learn something from their approach. They'll learn from you, and it's free. All it costs you a little bit of time.
Cool. Awesome. Thanks for the interview today. This was super helpful.
Yep, absolutely. Great talking to you, and best of luck in your job search. I know it's really tough out there. I'm hoping things are going to get better next year. We'll see how it goes.
Yeah, yeah, me too.
All right.
Awesome. Awesome.
Take care.
See ya.